guys, so the purpose of this video is for you to prepare for a potential retake on your energy resources quiz. And so I want you to know that the retake will be similar but not identical, so you do need to make sure that you're reading real carefully on it. Okay, so standard number 17 really just had one question, and that is about the consequences of global warming. So what I typed here are the three that we sang about or rapped about. So when it says looking for the polar ice caps to flow, people in coastal cities had better just go, that's referring to global warming causing rising sea levels and flooding coastlines because of melting ice. So you really do need to make that one thing, not two. Those are connected, the melting and the flooding. And then when it says farmers leaving, crops are steaming, head north where the climate's serene, the idea that good farmland honestly requires winter in order for the nutrients to replenish. And so we're already seeing shifts in strong agricultural areas. And then got it, malaria, here come more diseases. So a lot of diseases are spread through insects. And so where you have more tropical insects, you get more tropical diseases. So that was standard number 17. By the way, excuse me. Sorry about that. I am completely fine if you want to, instead of using those, include consequences that you have from your image analysis. So don't feel like you have to just do those three, because certainly there are many other consequences our planet is experiencing. So now standard 18, there are a lot more questions on this one about describing and classifying energy resources. So, and when I scored this, by the way, I marked through the right answer. So your original quiz would have right answers marked, but I still want you to watch and understand if there's any confusion. So a resource that can replace itself in a short period of time, we call that renewable. Remember, that's reproduction. That's how creatures replace themselves. A resource that will never run out is called perpetual. And then we get into the fossil fuels because they're still our most common energy resource. And the liquid fossil fuel is called crude oil. That's number 3. Number 4, the solid fossil fuel is coal. And then question number 5, this one is sometimes tricky. Which of these is not a step for making electricity at a nuclear power plant? Well, that means that you have to think about where nuclear energy comes from. And it comes from splitting uranium atoms, not from burning coal. Everything else in the process, like the turbine and the generator, would be the same, but no burning coal. So C is the right answer there. And then number 6, the final one on page 1. Sorry about that. One moment. There we go. Wind is actually a type of solar energy. The reason for that is the sun unevenly heats the air. So you get air masses that have higher and lower pressure, and air always moves from that high to low pressure. Okay, so as we flip to the next page, question number 7. The answer is biomass. Many poor countries depend on this type of energy. It's not like it's not used in wealthier countries, but biomass means burning firewood, burning dehydrated manure, and those things are cheap. That's why they're kind of common everywhere, especially in countries that are not a wealthy country. So number 8, all the following are perpetual resources except for nuclear. Now let's get to why that's true. So wind, solar, and hydroelectric. So water, hydroelectric, water is always going to be on our planet, just changing forms through the water cycle. The sun is not supposed to burn out for 5 billion years, so we can call that perpetual. And the wind is caused by the sun. But nuclear power is from, again, splitting uranium, and uranium is found in rocks. Now, here's the catch. It's not limited. There's still a lot of uranium reserves on our planet, but certainly it is a non-renewable resource. Okay, question number 9. It was really not just one question. So these are lists of resources, and you had to classify them as renewable, non, or perpetual. So going across the rows, sunlight is a P for perpetual. Coal is non-renewable, even though it comes from decomposed plant material. Coal can't reproduce with coal to make more coal. And currently on our planet in swampy areas, coal's being created, but it takes millions of years to get buried in the rock cycle. And then water is perpetual. Both fish and trees are renewable, and remember, uranium is non-renewable. Now, on your retake, you're not going to have these exact same resources, so you just have to use your mind and think through the classification. Okay, so what you might have found to be the trickiest part of this test was the the quiz, I should say, was this graph interpretation. So you looked at this graph, which is our energy consumption in 2010. And then also this graph, let me show you down here, which was our energy consumption in 2019. So we started out with the 2010 graph, and I wanted you to calculate our energy consumption in 2010 and what percent was from fossil fuels. So to do that, you had to go through the graph and you had to think, well, what are the fossil fuels? So you notice I put in arrows here. Coal, petroleum, which is like saying oil, and natural gas are the three fossil fuels. So when we added those together, it equaled 83%. So 37, 21, and 25% equals 83%. Now, my next question asked, what section of the renewables is really kind of like burning a fossil fuel? So as you look here, at that time, renewable energy was 8%, and then they take this 8% and break it down into wind, solar, biomass, geothermal, and hydroelectric. So when I say similar to burning a fossil fuel, we have to think, okay, fossil fuels were once living creatures. We know when they're burnt, they give off carbon dioxide. So what here is connected to living creatures and when burnt would give off carbon dioxide? And the right answer there, of course, is biomass. So number 11, biomass is burning a living thing like firewood, and all living things are made of carbon. So when they're burnt, they give off carbon dioxide. So that's why really biomass is similar, very similar in terms of pros and cons for use to fossil fuels. Okay, now you are focusing on this graph, which is the 2019 graph, which was the most recent one that I could find. And so I wanted you to still add up the fossil fuels. So that would be, again, petroleum, natural gas, and coal. And so as you added those up, whoops, I might have messed up. Sorry about that. As you added those up, you should have come up to 80%. So that would be question 12 there. Again, here it is. It would have been 80%. Sorry, I didn't type it. Adding up coal, petroleum, and natural gas. Okay, now we get to standard number 19 about how energy choices can impact global warming. And so now I'm back on track. I've got everything typed like I should. So standard 19, first of all, I wanted you to compare the fossil fuels. So the wording here, you really have to be careful about. In 2019, compared to 2010, the amount of fossil fuels did what? Well, it decreased because in 2010, fossil fuels were 83%. In 2019, they went down to 80%. So what impact does this have on global warming? It would decrease global warming, and now here's why. Less fossil fuel use decreases global warming because fossil fuels come from dead plants and animals. That means they're made of carbon, so when they're burnt, they make more carbon dioxide. Remember in our song, it said, the earth wants you to needs you to stop burning fossil fuels unless you want to be a fool. And that has to do with the carbon dioxide that's created. So it's actually a good thing in those 9 years that fossil fuel consumption has gone down. Obviously, it's still very high, still the most popular, but has decreased. Okay, now the very back side of your quiz asks about nuclear power. So let's check that out. What happened to nuclear power? Well, in 2010, nuclear electric power was 9%. In 2019, it's 8%. So what has happened to it? It is a decrease from 9 to 8%, and that is actually bad for limiting global warming. Now, why is that true? It would be a good energy choice to limit global warming because nuclear power comes from splitting uranium. Uranium is not carbon. No carbon is involved, and that could result in carbon dioxide. So we see, oh, look, the fossil fuel use went down. That's good. But also nuclear power went down when that is a resource that does not produce carbon dioxide. So we get into this. Oops, sorry about that. That should say 2019. And so should that one. So now we get into the renewables, and we see a definite increase in renewables. So this would be question 7 under the standard. We see the renewables go from 8 to 11. And that would be good for limiting global warming because most renewables, we also sometimes call them perpetuals in our class, create like solar and wind and hydroelectric create no carbon dioxide. But biomass is an important exception to this. And it does happen to be the biggest chunk. But it's actually a good thing that we're seeing this decrease in fossil fuels and an increase in renewables. So sorry for the few mistakes I had in there. I hope that worked, though, to help you correct your quiz and to prepare for your retake.